Hello everyone! Today's lesson is on solving inequalities, and you've done something very similar to this when you were working with absolute value. So our topic today is about solving inequalities using the four basic computations: addition, subtraction, multiplication, and division. By the end of the lesson, you should be able to create and solve your own inequalities. Let's get started. So you remember from last week, an inequality is a math sentence that compares expressions. So this is a comparison that tells us that x is greater than 7. Here, this tells us that d is less than or equal to -5, and here is q is less than 14. So it's a math sentence that compares expressions. We solve inequalities the same way we solve equations. We use inverse operations to get the variable by itself. And we also use the same properties for solving inequalities as we do for solving equations. So let's look first. We have the addition property of inequality. Let's take a look at this inequality. We have x minus 3 is greater than -10. Well, we need to have it as an expression where we have the variable by itself and the number by itself on either side of our inequality sign. So we solve just like we would with an equation. We do inverse operations. For this, we would add 3 to both sides of our inequality, and then we're solved because these 3's would cancel each other out, and we have x is greater than -7. Let's take a look here. X minus 6 is greater than or equal to -10. Oops. What do you think we should do? Right? We need to add 6 to both sides. This cancels out. Now we have x is greater than or equal to -4. Now for the subtraction property. We have x plus 7 is greater than -20. So we're going to subtract 7 from both sides of our inequality. And when we cancel out, we have x is greater than -27 because we're subtracting 7 from both sides. Why don't you give this one a try? What do you think I should do? I need to subtract 1.4 from both sides of the equation. So now I have my x by itself over here, and I have -9.4 on this side. Okay. Multiplication and division are very, very similar. There's just one small little caveat. Division property is first. So if we have 3x is greater than 3, we need to divide to get our x by itself. We divide both sides by 3, and our new inequality is x is greater than 1. Why don't we try this one? We have 4x is greater than -12. What do you think we need to do? Right, we need to divide both sides by 4, and that gives us x is greater than -3. Now, here's where the weird part comes in. If you are dividing or multiplying by a positive number, as we've done up here with these two examples, then your inequality symbol stays the same. The trick is if you're dividing or multiplying by a negative number, as we need to do in this case. In order to get x by itself, we need to divide by -5. So if we're dividing or multiplying by a negative number, then our inequality symbol switches sides. Let's try it with multiplication. We have x over 8 is greater than -5. What do we need to do? We need to multiply both sides by 8, or 8 over 1 if that's what you're thinking, because remember this is 1x over 8. So we can multiply both sides by 8. We have x by itself, and x is greater than negative 40 because negative 5 times an 8 is negative 40. Okay, on this one, how do we get rid of this? Well, we need to multiply by a negative 3. So if we're multiplying or dividing by a negative number, that's when we need to change the direction of the inequality. So I'm multiplying both sides by negative 3. So now we have y, and then we flip the sign, and it's greater than positive 6 because negative 2 times negative 3 is positive 6. All right, so just to remind you, if you're multiplying or dividing by a positive number, there is no sign change. If you're multiplying or dividing with a negative, you need to switch the signs. We're going to be practicing solving inequalities tomorrow, so be sure to write down any questions or confusions you may have about the concept.